All right, here we go again. All right, what we're gonna do is I'm gonna do things a little bit different here. This is a pre-recorded lesson, and we're gonna be covering, we're gonna be doing 10.4 and 10.5 today. And so I'm gonna pre-record it, but I'm actually, I am gonna come on today just to make sure that I get the attendance, and then maybe to discuss any questions or anything that came up. So here we go. We're going to start off with 10.4. And what I'm going to do is I'm going to do the PowerPoint presentation because there are good visuals on that PowerPoint. And then what I'm going to do is I'm going to come back and I'm going to work a few problems, a few extra problems that were similar to the lesson, the same problem that were on the lesson, because I really do like the way the PowerPoint presentation actually have the visuals that you can actually see. And we just kind of follow. And actually what I'm gonna do is some of the problems on the PowerPoint, I will actually work those on my iPad. So what we're gonna do is I'm gonna go ahead and get that, let's go ahead and get that up and going just to make sure that we are up and going. So I guess one thing I need to do is actually check to see whether or not it's working. So I'm gonna go ahead and share. Let me see if I can share this. I'm gonna do that. Let me share that and let's just see what happens here. It's not showing me what I'm sharing. Oh, so I want to share my phone. I got my phone. So let me. Yeah. I get the. All right, let's do it again here. Let's just see. Do that. Let's share that. All right, now we're good to go. Good deal. All right. So let's go ahead and get started. So what I'm going to do is we're going to start off with 10.4. And 10.4 is going to be that's going to be slopes and rates of changes. So let me go here and share that with you. Get that slideshow going. All right, so we got slopes and rate of changes. So what we're going to be doing today is I'm going to be introducing you guys to slopes. We're going to be dealing with recognizing positive slopes, negative slopes, zero slopes, and undefined slopes. We're also going to be finding the slopes of lines, and we also will be understanding slopes as a rate of change. Now, here's what we got to understand. If you're rising from left to right, okay, you're going to have a positive slope. So what you can do is you can imagine a little man. If he's walking up, if he's going from left to right, he's walking up a hill, that's a positive slope. If you're going from left to right, like we read, if the little man is going down the hill, that's a negative slope. If you have a horizontal line, that means you're running, but you're not rising. That's what you call a zero slope. And then if you have a vertical line, that the slope is undefined, okay? Remember that slope is rise over run. And so if you rising, right, but you're not running, is zero running, that means you have zero in the denominator, okay? So the rise or the change in y. So this is what slope is, guys. The slope is the rise or change in y. Just make sure I'm recording. It's the rise or change in y, and the run or change in x value. So we can kind of see right here, you got the rise, which is the rise, which is changing the y value, and then the run is going to be the change in the x values. Okay, and this right here down here is going to be the definition of slope. So we're going to use this right here formula right here. This is the formula that we're going to use in order to find the slope. So if we're given this point, x1, y1, and then we give them another point, x sub 2, y sub 2, then in order to find the slope, as long as x sub 1 does not equal to x sub 2, then we have this formula right here in order to find the slope. Man, let me just stop this right here right quick, like just to make sure I'm recording. Okay, I am recording. All right, good. Okay, so we're going to get here. Let me go ahead and continue to share. So that's the definition of slope. All right. So what I'm going to have here. So in this right here example, we're going to use 2 points. So we got these 2 points on the line, -4, 1, and we have 0, -2. And you can see that this, you know, if you put a little man on here and he's walking from left to right, he's going to be falling. So we already know that that slope is going to be a negative slope. It's going to be negative. So what we want to do is we want to use the 2 points to find the slope of the line and interpret the slopes in terms of rise and run. So we're going to take that formula that we had and we're going to plug this stuff in. Notice that we plug in the y values, which is 1 minus -2. And then we plug in the x value, which is -4 minus 0, which gives us a 3 over -4, which is equal to -3/4. So, and these are the intuitive things that we need to understand, I need to pay attention to make sure that we get the correct answer, because we know we got a negative slope. So we get an answer that's not negative, we know we did something wrong in our mathematics. Okay. So in this case, the rise is 3 units and the run is -4 units. Okay. All right, let's look at these right here. And I have these, let me just make sure. Cross 0. Yeah, let's work these right here. So we got, let's calculate the slope of each one of these guys here. So I'm going to go back. We'll stop sharing. I'm going to go back to my iPad here and we're going to work them out. Okay. So and then we'll look at it as well on the screen. So I'm going to share this guy. There we go. All right, so just make sure I got everything going. Calculate here. So make sure I'm using the right pen. So we're gonna have, looks like we're gonna have a -3 minus 3, and then we're gonna have a 0, 4. Okay. So what we're gonna do here is we got to use this formula. Our formula is going to be m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so let's label these points here. So if I label the points, this right here is x sub 1, y sub 1, x sub 1, x sub 2, and then we have y sub 1, y sub 2. So these are 2 points here that we have. All right, so what we're going to do is Let's go ahead and plug in. So we plug in, we're gonna have M is equal to, so we got y sub 2, which is 4, minus y sub 1, which is a negative 3. And then we're going to go here, go ahead and do the x's. We got x of 2, which is 0, minus x of 1, which is a minus 3. Now, if you look right here and you look at, these are good places to mess up because of those negative signs. So please don't get those confused. So now here, negative and negative is a positive. So we're going to have a 4 plus 3. And then here we're going to have a 0 plus 3. So my answer, or the slope in this case, is going to be 7 divided by 3. That's my answer here. Let's just make sure we're on the same page here. Go ahead and share this right here, guy. Let's kind of walk through that out here. Yeah, so this is what they got here. All right, so you kind of see what they got here. All right, let's go ahead and do the next one. So let me stop sharing. I guess I can do something a little bit easier and just say new share. I think that's about the best way to do it. All right, so let's go to the next problem here. So I have, once again, this is B. I have these 2 points. I have a minus 3, 4, and then I have a 3, 2. I can go ahead and label my points. My points are going to be x of 1, y sub 1, x of 2, y sub 2. Remember my formula. See, once you use this formula enough, it's going to become second nature to you. X of 2 minus x of 1. And we're going to go ahead and plug in. So we plug in, we're going to have a 2 minus 4 divided by 3 minus a minus 3. So here we're going to have a 2 minus 4, which is a minus 2 divided by, remember this right here, this little part right here is going to become addition. It's the same thing as 3 plus 3, which gives us a 6. So now we got to go ahead and reduce this as well. So we're going to have a minus 1/3. That's my slope. Remember that if you got a negative slope, you're going to be falling from left to right. Okay. Let's look at this next one here. So we got C. So we have a minus 2, 4, and we have a 2, 4. All right. So once again, go ahead, label my points: x of 1, y sub 1, x of 2, y sub 2. And then my slope, M, is equal to y sub 2, which is 4, minus y sub 1, which is 4. And then we have x of 2, which is 2, minus x of 1, which is a minus 2, which gives us a 0 on the top. And then we have you remember that's going to be positive. So we have a 4 here. Okay. So this gives me that my slope is 0. And remember what we said about the 0 slope. You're not rising, but you're running. So in this case right here, you know that we're going to have a horizontal line as well. Okay. All right. So let's do this last one here. Piece of paper here. This last one is going to be, say, A, B, C, D. So we have a 4, 5, and then we have a 4. It's like the 2. All right, so we're gonna do the same thing. X of 1, Y of 1, X of 2, Y of 2. And then my slope formula, M is equal to Y sub 2 minus Y sub 1 over X of 2 minus X of 1. Okay. So what we're gonna have here, we'll go ahead and plug in now. So we go ahead and plug in, we're gonna have a 2 minus 5 divided by 4 minus 4, which gives us a minus 3 over 0, which gives me a undefined. So this right here is going to be undefined. That becomes a problem. Well, not a problem, but we just have an undefined slope, which means that you're dealing with a, in this case right here, you're rising, but you're not running. All right. So what we're dealing with here is we're dealing with a vertical line. So these are the things that we know. Okay. All right. So let's look at this right here. Let's just make sure we did them all right. Don't necessarily mean that they did them right. It's either. But let's just kind of. And, they also actually graph these as well. So if you graph that other one, well, they plotted the points, and you can actually see the slope and see how it looks on that first one. So that's why this right here, that's why this is so much, sometimes this is good. So this is, just make sure, this is the other one with the negative slope. Remember, if I plot those 2 points and draw the slope, we're going to be falling. Okay. Same thing here. If I had these two, I get the 0, and I get a horizontal line. Right. Same thing with D. I get an undefined slope. Right. Just make sure. Which gives us a vertical line. Okay. So that's what we have here. So now, now this right here says find the slope of these 2 points. Now, typically what you're going to do is we're going to find a good grid point to where they actually hit. So that -3, this right here is 0, -3 is a good point. And actually 1, -1 is another good point. So let's just see what they use in their, the graph rises 2 units. So yes, that's what they did. See this graph, if you start right here on this -3, you're gonna go up 2 units, you're gonna run 1 unit. So then that means our slope is 1. Of course, on this right here, we know our slope is undefined on the B part. So you see how we did this right here? We're looking at this, you go this way, and you go up 2 units, but you run 1 unit. Okay. Now this right here says sketch the graph that goes through 1, 2, and having slope 3, 4. So let me just do that on here, because a lot of, I think it's better that we kind of see this right here thing. Let me get this right here going. So if we got, and I apologize, I didn't quite come prepared. So we have a point, and that point is going to be 1, 2, and then we have the slope. Then we have the slope is going to equal to 3/4. So let me just take you guys right quick. Like, let me share this guy. Share my guy again. Okay. So this is what we got. We have a point, which is 1, 2. And then we have a slope, which is 3/4. So you know that we're going to rise 3 units and we're going to run 4 units. All right. So let's plot this points. Remember this is our X part and this is our Y part here. So we're going to go, this is my X axis and this is my Y axis here. Now we always start right here in the origin. And so we're gonna go over 1 and we're gonna go up 2, 1, 2. So that's the point right there. So we're gonna use the slope to find another point. So all we need is one more point in order to draw a line. So we're gonna rise up 3 units, 1, 2, 3. I'm gonna run 4 units, 1, 2, 3, 4. So we got another dot right there. And if you want to, you can find it. You can keep going. 1, 2, 3, 1, 2, 3, 4. So that's another one. You know, you can make as many dots as you want. So once we get all those together, we're going to connect the dots with our line that goes through. And we're going to have look like that. Okay. So that's what we got. I'm going to start doing this share new in a minute when I can remember it. Let me that what happened. Now I gotta go find where we were. Okay. Okay. So we're gonna start just like we did. We're gonna start from that point, and then we're gonna do that. Make another point, and then we're gonna draw a line. Okay. The line passes through the points 1 + 4, and then 2 + 3. All right, it says when lines are used to model physical quantities in applications, their slope provide important information. Slope measures the rate of change in a quantity. So, even when you're dealing with, graphs and charts and things of that nature. So let's look at this chart right here. We got the distance Y in miles. So notice that we're dealing with the Y is going to be that's going to be the mile parts. That a boat is from the dock on a fishing expedition after X hours is shown below. It says find the y-intercept. What does the y-intercept represent? All right. So we find that y-intercept, we go right here, which right here is 0.35. All right. And so the y-intercept is 35. So the boat is initially 35 miles from the dock. That's where you started at. That's what it means. It says the distance y in miles that a boat is from the dock on the fishing expedition after X hours is shown below. It says the graph passes through the point 4:15. So at 4, you're at 15. And discuss the meaning of that. And what we know in that particular case is the point 4:15 means that after 4 hours, so if you go 4 hours, that boat is 15 miles from the dock. So, then after 7 hours, you at dock, okay? So find the slope and interpret the slope as a rate of change. If we took those 2 points and plug them into that formula, right? So we got 15, we got 4:15 and 0.7. We get that the slope is going to be -5. So the slope is -5. The slope means that the boat is going toward the dock at 5 miles per hour. So these are some good things that we can use. Here's another one. It says when a street vendor sells 40 tacos, his profit is $24. And when he sells 75 tacos, his profit is $66. It says find the slope of the line passing through the points. So we have these 2 points here. So we got 40.24 and 75.66. All right. So if we find the slope, once again, we just use the formula to find that slope. We get our slope is going to be 1.2. So the profit increases on an average of $1.20 for each additional taco sold. Okay. I would ask, are there any questions, but I'm forgetting that I'm recording this. So that's that section. And let's just go to the next section here. Okay. And, I may just, I don't know, this is, I don't want to pile too much on you at one time. But let me just kind of go through a little bit. We'll do half of this section right here, because we really only got 3 sections in this right here, up into 10.6. So we're going to do half. So I'm going to go ahead and open this guy up, and I'm going to do this the same way. So tell you what, before I do that, let me work 1 or 2 more problems that you're probably going to see on your homework. Okay. So let me, before I actually go to this section right here. Come on, buddy. All right. So let's do this right here. I had a couple more problems that we worked on. So let me stop sharing. And I'm going to share this guy again. So I'm going to share that. All right. So let's work this right here. Let me find the slope, and I'm gonna mix it up a little bit. So we can find the slope of the line that passed through these 2 points. Find slope of a line passing through. And we're gonna use let's use 1/3. I promise you see something like this right here. Minus 2/7. And then you have a minus 2/3. And then we have a 3/7. This is not so bad because we already have common denominators. So once again, we got x1, y1, x2, y2. Okay. Remember my formula is going to be m is equal to y2 minus y1 over x2 minus x1, right? So what we're going to do is we're going to come here. We're going to plug in. It's going to look kind of ugly at first. So we got 3/7 minus a minus 2/7 all divided by, here we have a minus 2/3 minus 1/3. Okay. So this is when those addition rules and all those things is fixed to come into play. So now remember here, you're going to be adding, all right? So here we're going to have we have a common denominator, so we're good right here. So then we can add the numerators. So we can add these 2 numerators here up. That's going to give us a 5. Now, here at the bottom, remember this right here. The signs are the same. Make sure I don't lose that little minus. The signs are the same. So since the signs are the same, we add to absolute values and then we keep the sign so that we know that we're going to have a negative here. We already have a common denominator, which is 3. And then a -2 plus a -1 is a negative. I'm sorry, a negative. It's going to be negative, but this is going to be 2 plus 1 is going to be, maybe that right there. It's going to be 3. Okay. Which that actually helps us out a whole lot, man. That actually brings us out the whole. So we're going to have a 5/7 divided by 3/3 is 1. So that's a -1. So we're going to end up with a negative 5/7. Okay. So I know a lot of you guys didn't like that, but this right here little part, let me just kind of go into detail on this little part right here, because I know this is ugly right here. So let's come over here with that. So we have 5 divided by 7 divided by -1, which is the same thing. Remember that division is the same thing as multiplying by the reciprocal. So what we're going to have is we're going to have 5/7 times the reciprocal of -1, which is 1/-1, which is equal to 5/-7, which is equal to -5/7. And that's how we got that. Okay. That's what we're looking at. All right, let's look at this right here. Let's look at another one of these right here, guys. In this case, background. All right, let's what we're gonna do is let's graph this right here, guys. So let's just say I'm gonna give you a slope. Come on, buddy. So what I'm gonna do is I'm gonna get my Cartesian coordinate system going on here. So we got our X, we got our Y. So what I'm gonna do is I'm gonna give you guys a point. I'm gonna give you guys a point, which is just use -2, 2, and then I'm gonna give you guys a slope. So my slope is equal to -3. And what I want you guys to do is to graph this right here. So you'll probably see some of these in the homework. So we got a point and then we got a slope. Now remember that this right here slope, this is the same thing as -3/1, which this is my rise and this is my run. All right. So that's what we're going to use. All right. So let me go ahead and get my color graph here. These little dots right here, get on my nerve. All right. So we're going to plot this point right here. Remember that this is my X value and this is my Y value. So on my X axis, I'm going to go over to the left 2 units, and then I'm going to go up 2 units. So we got a dot here. So then I'm going to use my slope, which instead of rising in this case, we're going to fall. We're going to go down 1, 2, 3, and then we're going to run 1. So we got a dot here. You can find another point too. Just do the same thing. 1, 2, 3, then 1. And then we're going to take our straight edge and we're going to draw a line through it. Let's give it to, and this right here makes sense too. This makes sense because if you go, if you guys go from left to right and you had a little man that was walking here, that the slope is negative, but I was going from left to right, this guy gonna be going down the hill. I mean, he's gonna be going down a steep hill in this case. He might hurt himself. So that's what you have, and that works out really good. Okay. Okay. So that's kind of what I want to see on that. And then let's stop sharing. And let's go to the let's go ahead and go to section 10.5. So we'll probably do just half of this right here because I don't want to pile too much on you at one time. So we'll do half of this right here. So what I'll do is go ahead and share this screen. Share this one. All right, go ahead and play this slideshow here. All right, so this right here is slope intercept. All right, so now we got what we're going to be doing is determining a line and finding slope intercept form. So that's a form that we're dealing with. All right, and I tell you what I'm going to do is I'm just going to go through this presentation. And then I'm not going to work any additional problem. I'm going to work the problem. We're going to go through the problem on this presentation so we can kind of see what's going on here. That's probably going to drive me to work a couple of more problems because I just can't stop there. But we'll just see. All right, so what we're going to do is we're also going to be finding slope intercept form, and then we're going to be working with parallel and perpendicular lines. I think we kind of did that a little bit the last time we were in class. So the slope of a line M and the y-intercept, we usually call that B, is given by y is equal to mx plus b. This is the form that everything needs to be in, because if it's in this form, y is equal to mx plus b form, we can easily pick out the slope and we can easily pick out the y-intercept. So this right here is a slope intercept form of a line. Okay. As you see in this figure right here, you can see that you have the y-intercept, which is 0, 3, and then you have the slope. So we look at the slope here, you go up 2, and then you run 1. So my slope is 2. So this right here line gives this equation, which is y is equal to 2x plus 3. That's why we got that. All right. So it says for the graph, write the slope intercept form of the line. So now, right here, we know that this thing crosses the y-axis right here at 0, 0. So we know my y-intercept is going to be 0. That my b is equal to 0. Okay. Then my slope in this case right here. So if I go, it's going to be a positive. Well, I'm sorry, it's going to be a negative slope because we're falling from left to right. So if I get right here on this point here, which is I'm right up here. I keep losing my cursor here. I'm right up here at we had -1, 3. So at this point here, this -1, 3, I fall right down to 0. So if I get from that point to 0, 0, I'm going to fall 3 units, and I'm gonna run 1 unit. So it appears that my slope is going to be -3. All right. So let's look at that. So yeah, my slope is -3. So here is my equation. Y is equal to -3x plus 0. All right. And that's why we have that. All right. So we're going to sketch a line with slope 3/4. Got 3/4. And then we got y-intercept is 0, -2, right? So the first thing we got to do is the y-intercept is 0, -2. And I think there is an indication that the graph rises 3 units for each 4 units. I think they kind of making that a little wordier than what it is, but you can kind of see it right here. So if we get a visual interpretation of it, right here, we're at 0, -2. And then we can rise up 3 units and then run 4 units, but I don't think. So that's what we get. That's what the line looks like. It's kind of off a little bit, guys, we see right there. But we can let that go. So this is going to be my equation. But let me just look at that right there, because I think the way let me do this right here, new share. I'll do this right here. So let's go back to my little screen here. All right, the way I see this right here. So in this case, we have M is equal to 3/4, right? And then B is equal to 0, -2, or I can just say B is equal to -2. All right. So now my formula, here's my formula, guys. My formula is Y is equal to MX plus B, right? So all you're going to do, what we're going to do is we're going to take these guys and we're going to substitute them in. So we're going to substitute this guy in, and then we're going to substitute that guy in for B. And it's going to look like this. So we're going to have Y is equal to 3/4 X plus a -2. Or you can just kind of get eloquent with it. Y is equal to 3x, 3/4 X minus 2. And there we go. Okay. Hopefully that makes sense. And that's how we arrived at that. So now let's just say, for instance, on this case right here. So let me, let's do this right here. So I have Y is equal to 4 minus 3x. Now, what it's saying that you need to write this right here in slope intercept form. All right. So that's what we're going to do. We're going to write in slope intercept form. So we got this right here, equation here. Remember that my slope intercept form looks like this, guys. It looks like y is equal to mx plus b, where the x portion is on the left. We got a problem right here. But we can do that, guys. We can rewrite this. This is the same thing as y is equal to 4 plus a minus 3x. That's the same thing. And remember that when you addition is commutative. So it doesn't matter what order that you add something in, it's still the same thing. So I can flip-flop these guys right here, and I can have y is equal to a minus 3x plus 4. And I hadn't changed anything with that equation. So this right here would be my answer. Hopefully that makes sense. I don't know why, for some odd reason, I want to keep asking you guys, I have any questions, but I'm forgetting. I'm just recording this right here. Okay, so that's what we got there. Now, if you want to graph it, then it's a then graph. So what we're going to do is we're going to plot that intercept, and then we're going to use the slope. So we're going to fall 3 units, and then we're going to run 1 unit. All right. So we're going to fall 3 units here. Then we're going to run 1 unit, and we're going to put another dot right there, and we're going to draw a line. And that's what it looks like. All right. I don't want to get into the parallel and perpendicular line. Let's just kind of go with this right here for right now, and then we'll pick this up next lesson. So next lesson is going to be the remainder of 10.5 and then 10.6. Okay, guys, I appreciate you guys' participation, and you guys have a good day. Thank you.